Hi everyone. Okay, in this video I'm gonna discuss your homework 9, which is the topic of lectures 32 and 33. So here is the homework itself. It is the same arm that we analyzed last time in Abacus. This time, this is subject to this force, the cyclic force. Starts from 0 up to 1600 and goes down. And based on these information and the cyclic loading, a series of information is asked from you to calculate. So what we're going to do is first, in the first section, you have to get your strain values from this minimum and that maximum load, and then continue your calculations. So let's check the loads first. The loading starts from 0 and goes up to 1600 and comes down and does that again. And what you need is only the values from minimum and maximum. So you don't need the values in between, and that's why we won't do the cyclic loading in Abacus. We only get the values for this one. Since this is already 0, we already know that everything would be 0 for this one. So we will get the values of strain when this load is applied, which is basically what you did the other time. Okay, so I will come to Abacus. What you first need to do before you submit your job is you have to go to field output requests. Here there is already one default field output. Double click on this and you will see these. Expand the strains, and this total strain components, this is automatically inactive. You have to check this and then click OK and then submit your job and run it. And I already done that, so I'll just go directly to results. So here again, like the last time, we take these out from picture. Let me click on this, and like what we did last time, the stress is here, the highest maximum one. This is stress is here, and if you forgot how to show this, you have to come here and in the limits click on this, and this is the value, and this is the node number. We need this to get the strain values. Now to report the strain, you see you can see them here if you come here and like put on a strain and then pick any one you want. But a better way is to get all of them at the same time. So let's see, you come here in report, field output, and then you're already on step 1 and frame 1. You don't need to change any of this. You request the strains, just uncheck this just, let's say, irrelevant. It's either one of these, so it makes you confused. So, and then in the setup, this is the default name, and you better select a folder that you have access to. I'm gonna put it in my iDrive, and then I don't want to append to file. I want to create a new file. You see, sometimes you need to get a lot of information from Abacus, and you want all of them to be combined in one file. So every time you get your report, you check this. But this time we only want one, so we uncheck this. And here, let's see. Oh, in the previous one, I had to change this to unique nodal. We want these strains on nodes. Again, in the setup, I'm gonna sort them by their max principal strain, and just we're gonna search for this node. And since I already know that this must be a high number, I will sort this by this max principal and in a descending way. And everything is okay, and I click on OK. And I already have a file named Abacus RPT, so I override it. And now we have to go and find this file. And if you don't see this, just refresh once. Sometimes it won't show. I right click on this and open it in Notepad. Okay, and this is the point that I'm looking for. In my case it's 49393, but in your case it might be a different node. You have to check it from here. The node with the highest von Mises stress. So these are the parameters that we're looking for. These are all the strains. And let me open another notepad just to keep these. I'm gonna copy this here and copy the second line here. And we're done with this file. Okay. So we got our numbers, and according to part 1 of your homework, you have to calculate an equivalent strain. So the equivalent strain can be calculated in two ways, either using your principal strains or using your regular strains, XYZ and sigma XY and the rest. Just know something, that these are tensorial strains, the ones for the shear. Abacus gives you engineering strain, so you have to divide these 3 by 2 if you want to put them here. So your better option is to just go with this one. These principal strains are this one, and this one. These first 3 are your principal strains, and the rest are X, Y, Z, and the rest. And if you want to check, you can check both of them, but remember these 3 should be divided by 2. Okay, and from here you get your E. And in part B, you have to calculate a bunch of things, which all of them are similar to what you did in lecture notes during the class, and it was example 2. It's similar to example 2 pretty much. So the first thing you need to do is, you already have a S max, which is the von Mises stress at the maximum point. The number for my calculation is 170 megapascals. But yours should be the same, probably. So you have this S max, you have this E max from this calculation. And what you need to do is to calculate the inelastic strain and stress. These were calculated based on elastic assumptions. So here you have two variables or two unknowns, and also you have two equations based on them. So the easiest way to do this is just to these two, the multiplication of these two is a number, and okay, my Siri started talking for some reason. I don't know. This is a number, and you can take the sigma to this side, so it becomes this number divided by sigma. So this becomes epsilon equals some number divided by sigma, and then you can take this and replace this epsilon with that number. So this becomes an equation solely based on sigma. Now to solve this equation, which is a nonlinear equation, you have to put it in some form in MATLAB to solve, and this file you have in your icon. So download this one, and this belongs to example 2. And if you look at your example 2, you can see how this MATLAB file works. The numbers are specific to this example, and you can change them to the numbers of your homework. But I will go over this as well. Or let me just explain this on this example. First, what I said was after you calculated Emax, and you also need these two values, n prime and k prime. And for k prime, you have all the required information, this, and also for n prime is based on b and c. You have them on your problem statement. And then you come down here in the same way. You take this one to the right hand side, and then replace this epsilon max with the sigma, and later put it in the MATLAB. So here we have created a function called some function based on sigma max, which equals 9.6 or sigma max. This 9.6 or sigma max minus this value to the this value. This is basically your function, and you want to set this equal to 0 and ask MATLAB to solve it for you. You see, after you put that number over sigma, you take this to the left hand side again, right hand side, sorry. So this becomes 3 terms equals to 0. So just put these 3 terms in here, and you say sigma max equals f0, which finds the 0 point for this function, and this is some interval that you want the software to find the number in between these two numbers. And you solve this and you get sigma max, and later you can get the epsilon max. And then there's another thing, delta sigma and delta epsilon, which in your case, since your 0 point values are 0, sigma 0 and epsilon 0 both are 0, you just directly put delta s and delta e are equal to S max and E max in your homework. And the only difference between these two calculations is that this has a 2 both at here and at the bottom. So again, using these equations here, this is the same for the second part. You have 2 here, you have 2 here. Just change these values based on your homework. And what you get is values for delta, sigma, and delta epsilon. And one more thing we need to calculate is sigma m. It's the mean stress, and you already got the values for these based on these calculations. So you get sigma m, and your work is done for the second part, and also the third part, by the way. For the fourth part, you need to calculate the number of cycles that it can go through. So again, you have this equation here. You put all the numbers, and this equation is the same calculation, one parameter in a linear equation. You want the 0 point. So the third equation here in MATLAB is for that. Just change the numbers accordingly. And by doing so, you can get the NF. Just remember one thing, that in this example, your stress was high. I mean, relative to your homework and also relative to these high stress values here. So what you got was a number less than 10,000 cycles. Here your stress is lower than that, way lower than that. We have 170 megapascals. In the example and lecture notes, the value is like 10 times that. So you got a lower number of cycles, but in your homework, after you calculate, you're gonna get way bigger than this. So don't worry if you got a high number. And later, at the end, it says there is some kind of defect in your material. So because of that defect, and this notch factor is 2, you have to calculate again all these things that you did and find out how many cycles based on the presence of this defect you can put this arm through. So in that case, there is no similar thing in this example. What you need to do is, first, I'll come down in your lecture notes. Here it says if you have a defect, you can calculate these inelastic stress and strain based on this equation. That notch factor that was on the problem statement comes here, squared, and this equation changes, and also this equation, so you have to calculate all these based on these new equations, and then again put it in the Romber Osgood calculate in this one, the Coffin-Manson marrow, and again calculate the new number of cycles, which must be lower than that because you have some defect. Here you have this KF, which means notch factor, and this is calculated based on stress concentration factor, KT. In your problem, you just directly have the notch factor, so you don't need to worry about having KT. You just already have the KF and put it here and do your calculations. So I think I discussed everything you needed. Yeah, just try this, and if you had any questions, you can send me an email and ask. Thank you.